So section 1.2 starts to draw some distinctions and increase your vocabulary in terms of statistics. The vocabulary we need to understand the most is right here. And these ideas are going to permeate through the course. The difference between a census and a sample, parameter and a statistic, those are really important concepts. So hopefully you have this document open up so that you don't have to spend so much time copying things down, and you can spend more time trying to figure out what all these things mean. Now we're going to start out with a nice general definition of a population as the collection of all elements, that is scores, people, measurements, and so on, in whatever that you're interested in studying. So it's complete in the sense that it includes every object or subject that you're going to study. That's your population. Now, if you have a population and you collect data from all of it, then that's called a census, taking data from everything in your population. A lot of times that's not very practical. So you have to get by with a subset of that, and that subset is called a sample. So census means you're taking data from the whole population. Sample means you're just collecting data from a subset. Sometimes it's impossible, or at the very least, very difficult to conduct a census. Now, in the United States, the Constitution mandates that we take a census every 10 years. But is it really a census, or is it a real good sample? Well, does everyone respond to the census? What do you think?
No.
No.
There's a lot of people that don't. And it's unfortunate because our representation in Congress and tax dollars that we get depends on the number of people that we have. And you can't adjust that with statistics. I mean, you can and you can't. We have the capability of doing it, but the Constitution won't allow us to use adjusted numbers in our census counts. So all we can work with is the raw numbers until they change the Constitution. Really what we get every 10 years is a very, very good sample, but it's not a census. There's a lot of people who are missed. We started realizing that there was an undercount in around World War I, World War II, when a lot more minority populations started showing up for selective service than we thought were out there. We started realizing, hey, wait a minute, we're missing some people. But unfortunately, we can't adjust those counts. Now, what do you do with all that data that you collect? Well, if you take a census and then you calculate some numerical measure that describes that census, maybe like an average, then that number that you get is called a parameter. That same calculation based on sample data is called a statistic. So if you have a census and calculate some numerical measurement from that data, it's a parameter. If you have a sample, then you get a statistic. So maybe I should write that down in kind of a little visual format. So population, and actually, let's do it this way. So census goes with parameter, and sample yields a statistic. So to decide what you're looking at, you're going to have to take a look at the data and decide, do you have a sample or a census? And that'll tell you if your data represents a parameter or a statistic. So we'll do a few examples like that. And let me see if I can't find that page here in our book. I think I'm gonna have to skip up a few pages. Let me just jump to the right spot. That's gonna be page 23. So we'll just jump up here to 23. Okay. I want to look at problem number 6 to start with. A recent California health interview survey included 2,799 adolescents in California. So it says, identify whether the given value is a statistic or a parameter. Well, 2,799 adolescents in California, does that sound like a census? Does that sound like you got data from everybody who's an adolescent in California?
No.
No. I'm thinking that wouldn't be, that'd be less than a census, even if you're just talking Los Angeles, let alone all of California. So yeah, that's clearly going to be a sample from which you're going to calculate a statistic. So for problem number 6, that's going to be a statistic. Let's move up to problem number 10, which actually is going to ask us to look back at problem number 9. In a study of 400 babies born at 4 different hospitals in New York, it was found that the average mean weight at birth was this many grams. In that same study, 51% of the babies were girls. Is that 51% a statistic or a parameter?
Parameter.
Parameter?
Yeah. Parameter.
There's some disagreement here. Hash it out. Do you think that the 400 babies represents all the babies born in New York?
No.
Or all the babies born in these hospitals?
No.
I'm guessing that there's a lot more babies born in the state of New York. In which case, those 400 babies would be just a
Sample.
yes. Good. And if that's a sample, then the 51% is a
Statistic.
statistic. Good. Problem number 12. The average mean atomic weight of all elements in the periodic table is 134.355 AMUs. So,
That's a parameter.
Parameter.
yeah, the all right, so there's only so many particles that can fit in a nucleus of an atom. And so that gives us a finite number of elements on the periodic table. So if you're conducting a census, if you're getting data from all the elements in the periodic table, that's a census. And the values that you calculate from that data are going to be parameters. So that one's a parameter. This morning, they were talking on the on this program I happened to be listening to, caught a few minutes of it, about the 158 moons in our solar system. And I thought, wow, that's a lot of moons. I know Jupiter and Saturn have a ton of them, but even Mars has a couple of them. They're really small. One's called Phobos, one's called Deimos or something like that. But Phobos is only like 6 or 7 miles wide. So pretty small for a moon. But you could still calculate the average size of all, average diameter of all the moons in the system, in a solar system. Now, would that average be a statistic or a parameter?
Parameter.
Yeah, it'd be a parameter because it'd be for all the moons in the solar system. So it'd be a parameter. Good. Okay, let's move on and dig a little deeper into types of data and things like that. Now, there's going to be a couple different categorizations of types of data. And so let's go back to our handout. One thing we're going to look at is discrete data versus continuous data. So that's one breakdown we want to look at. The big difference is discrete data can only take on a finite number of values, whereas continuous data can be anything within an interval. So I'm trying to just highlight those two. There you go. So you've got discrete and continuous. Discrete data would be like the number of TVs that you have in your house or the number of people who vote. Basically, and typically, it's going to be things that you can count. Now, the thing about things you can count is that they have to be integer values, typically. There's other little ways you can have discrete things as well, but it has to be in a correspondence with the integers. Continuous data can be data that can be anything in an interval. So it could be any fraction at all. When you're talking about height, weight, blood pressure, things like that, that can be anything in some range, that's continuous data. So let's
Quick
do a few
question.
examples. Yeah, Aiden, please.
Despite like the massive number of something, for example, of the number of stars, it still would be discrete data because it has to be within that single integer value.
Yeah, that's a great example. Yeah, there's billions and billions of stars, but you know, it's a discrete number because you can't have half a star. You can't have 3/4 of a star or square root of 3 stars, right? They have to be integer numbers. So that'd be an example of discrete data. Yeah, nice example. I like that one. That's a cool one. Good job, Aiden. So let's turn our attention to some of the problems in the book then, just to give you kind of a feel of what those look like. And let's see. I want to take a look, start at problem number 14 here. Determine whether the data are discrete or continuous. So in problem number 14, it says, among the subjects surveyed as part of a California health interview survey, subjects were randomly selected and their heights are recorded. So how tall somebody is that discrete or continuous?
Continuous.
Continuous.
It's continuous. Your height can be anything in some interval. Now, I don't know, what the smallest babies born were, but I do know that Robert Wadlow was the tallest human being ever. I think he topped out at like 8'10" or 11 inches. Interestingly enough, he died in Manistee, Michigan, and there's a store up there that has one of his shoes that he wore. And anyways, but 8'10", that's huge. But your height can be anything on some interval, from whatever the low end to all the way up to 8'10" on the top end. But because it can be anything, it's continuous. Let's jump down to problem number 16. The clerk of the U.S. House of Representatives records the number of representatives present at each session. What do you think, discrete or continuous?
Discrete.
Discrete.
Yeah, discrete, because you can't have a fraction of a person present, so that one's discrete. And let's flip over to the next page and do a couple more here. Problems number 18 and 20. I don't think the problem's on my end. This seems like this page is load really slow. But criminal forensics, when studying the relationship between the lengths of feet and the heights so that footprint evidence at a crime scene can be used to estimate the height of a suspect, a researcher records the exact lengths of feet from a large sample of random subjects. So the length of somebody's foot. Are going to vote for continuous.
That'd be discrete.
Why do you say discrete?
Probably just because from the verbiage used, like exact lengths of feet.
Okay, but
Well, because usually when you count a foot, you count like the inches too. So it'll be like a fraction.
Yeah, you can. In fact, the only thing that limits us is how good we can measure something. But it can be anything, right? I mean, Robert Wadlow had like a size 22 foot. I remember seeing his shoe, and it was enormous. I've got big feet. His dwarfed mine. I just couldn't imagine a human being so big. But you know, you can have feet that are any length in between, and your feet doesn't like jump. You don't go from a size 12 to a size 13. I mean, you slowly increase the size from smaller to larger from everything in between. So it doesn't stop at just discrete values. It can be anything in between. So well, I appreciate your help here. Thank you. Are you convinced and happy that that's a continuous there?
Yeah.
Okay, thanks, Frank. Texting fatalities. The Insurance Institute for Highway Safety collects data consisting of the number of motor vehicle fatalities caused by driving while texting. Of course, anything more than 0 is a real tragedy. But what kind of data is this?
Discrete.
Discrete or continuous?
Discrete.
Discrete.
Yeah, it's discrete. It can't be like 3.6 crashes. It's 3 or 4 or 5 or 6 or whatever, but it can't be things in between. And because it can't vary on an interval, it can't be those things in between, that's going to mean that you're stuck with the conclusion that it's discrete variables. So, good deal. All right. Let me introduce some more terms here for us. And again, I'm going to go back to our handout. And we're going to scroll down to these terms. These are different levels of measurement. So the last two pertain to continuous data, but we'll start out with kind of like one of the lowest levels of measurement is nominal measurement. This is data that's just basically a collection of names, maybe colors, or other labels like Democrat and Republican, those kind of things, but they're just names. And even the name nominal does suggest names. Ordinal data is a little bit more organized. There's a little bit more structure to it than nominal data. So in ordinal data, your data can be arranged in some order. So it could be rankings, it could be order of preference, it could be letter grades, those kind of things. But the thing about ordinal data is that you can't necessarily subtract things and get a meaningful difference. I mean, if you're looking at the quality of your blind date, excellent, good, fair, and oh my God, you can't exactly subtract those things and get some kind of a meaningful difference. But you know, there is still some order and structure to the data. It's more than just names. Now beyond that, it gets a little bit murky in these next two. Interval data and ratio data refer to continuous data that in the one case, interval data is data where you can subtract things, the difference between values is meaningful, but there's no natural zero or starting point. Whereas ratio data has that zero starting point, and the difference is, in ratio data, it makes sense to say something is twice as much as something else. Something is twice as tall, or it took twice as long to happen. Whereas you can't say that with interval data. And the example that best fits into interval measurement is temperature in Fahrenheit and Celsius. Now, I'm sure that if you go far enough north up into upper Canada, you could probably find a spot that was maybe 35 degrees Fahrenheit today. And if the temperature outside is 70 degrees Fahrenheit, does that mean that it's twice as hot here as it is further north in Canada? Not exactly. No, because Fahrenheit scale doesn't work that way. 0 degrees Fahrenheit doesn't mean that there's no temperature and no heat. It's just not the way that the Fahrenheit scale works. 0 degrees is actually pretty warm compared to absolute zero. Does anyone remember where absolute zero occurs or what scale measures absolute zero?
No.
Yeah, that's okay. You don't have to be physics majors, but I'll help you out here. It's degrees Kelvin. Degrees Kelvin. That's where 0 degrees Kelvin is as cold as it could get. Degrees Kelvin is as cold as it can get. And the reason I mentioned 0 degrees Kelvin is because if you increase temperature from 1 degree to 2 degrees Kelvin, this is twice as warm as this. It makes sense to say that in the degrees Kelvin scale. So degrees Kelvin is ratio data. Whereas degrees Fahrenheit and Celsius, well, that's interval data. It doesn't make sense to say that, today is twice as hot as, a day early last spring, because we're talking about Fahrenheit and Celsius. That doesn't work. It gets a little murky, and I understand that, and I have sympathy for you on that. It's not something I'm going to test you hard on, but at the same time, it is a distinction that I'd like you to be at least a little bit aware of, because it does come up here and there. So they're tough, but we're going to practice them. And let's do that with some examples from the book. So, a question?
Yeah, can I interval level measurement? Can you give me another example of that?
Yeah, let me think for just a second here.
Okay. It doesn't have to be right now. Maybe we'll see an example in the book, I guess.
No, I'd like to come up with one. I mean, it's a little tricky. I'm trying to think of, like dates. So for instance, let's see. And this isn't perfect.
Below sea level be one?
Well, I think sea level has a natural zero, so that would probably be ratio data. But if you're talking about the year that something happened, if something happened in 1932 and something happened in 1964, you can subtract these, but I guess there's not exactly a natural zero here. I mean, well,
pH levels?
No, pH levels have a natural zero. Well, let's think. Yeah, can you actually get down to 0 pH? I don't think so. And maybe, I don't know.
So
Who would
for
wanna be
ratio,
around these
sorry,
subs-
but for
wanna be
ratio
around it
data,
if
you
you
need
could.
0.
Say again, Jalal?
So for ratio data, you need 0 as a starting point.
Yeah, you need a natural zero as a starting point. And
Okay.
yeah, there's one I remember coming up with regarding the year. And I'm just not able to bring that one to mind right now. For right now, let's do a couple examples in the book. And there's really only going to be one example that you're going to come up with that's going to be interval data. And we'll see that one. And that's going to be pretty much where we're going to limit things. But let me scooch over to our book again. That was right here. So we've got these 4 levels of measurement to choose amongst. All right. Aiden, whenever you want to type those in, that'd be great. So exit polls. For the presidential election in 2016, ABC News conducts an exit poll in which voters are asked to identify the political party as Democrat, Republican, and so on they're registered with. So what kind of data is the party that you're registered with representing?
That would be nominal because there's names to them.
Yeah, your data is just nominal. So yeah. Let's move down to the next one, problem number 24. In a study of fast food service times, a researcher records the time intervals of drive-up customers, beginning when they place their order and ending when they receive their order. So the time that it takes them to get their order. What kind of data is that?
Would that be interval level?
It'd be a least interval, okay? Let's rule out a couple. Let's rule out nominal. The time it takes something to happen is not just a name. And it has a little bit more structure than ordinal data because you can subtract them. There's meaningful differences. So it's either going to be interval or ratio. Now, my acid test for these things is, does it make sense to say something is twice as much as something else? Could it take one individual twice as long to get their order as somebody else?
Good.
Is that
Yeah.
possible?
Yes.
Now, twice as much or twice as long is a ratio. So if it makes sense to say that in the context of your data, then that's ratio data. So I would go with ratio. It's a little bit more structure than just interval data. So this one's ratio data. Are we okay with that, Jess? I think
Yep.
you were leaning towards interval. Okay.
Yep.
Thank you. Thank you. And down to body temperatures. Body temperatures in degrees Fahrenheit. Well, what did we say about degrees Fahrenheit and degrees Kelvin?
We said interval, right? Or
Interval.
okay.
That's
Interval.
exactly what we said. It's interval.
Oh, so the Kelvin was interval. Okay,
Kelvin
I thought
was
it
ratio.
ratio.
Kelvin was
Oh,
ratio.
Okay. Okay. Just making sure.
Yep, not a problem. So I think it was Aiden or somebody else mentioned that pH is interval data. How acidic or basic a substance is doesn't really have a natural zero. Zero is just kind of like in between acidic and basic. Now, like I said, I'm not going to make you study physics to pass this class, and that's about the last of our physics that we're going to need. But pH is a good example. Okay. Interval. So I'm just writing these things down so we can keep up with some notes here. And let's take a quick look at the chat. SAT scores, credit scores. I'd have to think about those. So thank you. Thank you. All right, one last one, kind of by way of a bonus. So again, we want to apply ourselves and think about these 4 different levels of measurement and what kind of data you would have if you collected as part of a class project in statistics the last 4 digits of somebody's social security number. Now, I'm not going to worry about the fact that we're going to average these things together. Let's just think about the data itself here, the 4 digits, the last 4 digits of your social security number. So what kind of data would that represent? So is it nominal, ordinal, interval, or ratio?
Would it
I'll tell
be
you what.
ordinal?
Let's eliminate a couple of these things. Could it be interval or ratio? Not
No.
really, because it can't be like everything in between. You know, if your social security number ends in 5555, you can't have somebody else with 555.1 or 0.2 or anything like that. It's just discrete values. So it's not going to be interval or ratio data at all. So a smart person would eliminate a couple and then choose between what's left, nominal or ordinal. In my way of thinking, what do we use statistics, or what do we use social security numbers for in this country? Use it to
Identify someone.
Yeah, use it to identify somebody. That makes it kind of equivalent to a name. And that's it. I don't think you can order somebody saying that, oh, so-and-so is better because they hire a higher statistic or a higher social security number than you do. The
Right.
order doesn't really mean anything. It's just a number. And in that sense, I feel that it's nominal data for problem number 31. Yeah, I mean, social security number is used to identify you. So basically it's taking the place of a name. Whew. All right. Guys hanging in there?
Yep.
Yes.
Yep.
Okay.
Yeah.
Thank you. Thank you. Let me pause here. Let me see. So, you know, 4 hours is a long time to stay in a stat class. Actually, you know what? I think we're done with this section, so I'm going to stop the video there, stop the recording.